Good morning, everyone. So before I start, there's two things I want to mention. First thing is I really appreciate the organizer to give some opportunity. After I watched some of the YouTube video for the Nextflow Summit, it was one of my bucket list. So now it's dream comes true. Second thing is thank you. The second thing is that, so I always have the jinx when I attend the conference, give a talk, and they only assign that the rest of the day. So I always nervous until the end. But fortunately, I'm the first speaker, so which means I can fully enjoy the conference. So yeah. So today I just try to introduce some of the story and from our group and how we can try to pay off the technical debt from the publication and to make something sustainable and robust work pipeline. So it's a story about the AI-MARRVEL. Before I just try to share my story, the first thing is that I just try to introduce what AI-MARRVEL is briefly. Basically, this is a tool to identify causal pathogenic the variant or genes, and with some which is associated with some human phenotype or symptom. And this is a specialized Mendelian disease, and so basically this is a pipeline with some VCF and some of the list of the HPO terms. After we just take the VCF file and we are just trying to encode each variant into a feature space. A feature space contains lots of information about the variant, and which means that one single nucleotide or some variant is going to become the vector. And using this vector, we are just try to build some model and using the XGBoost, and so try to predict whether this variant is going to be causal or not and associated with the phenotype for the sample. And then so just try, this is to show this, this shows how we can train the data. We start using the internal data provided by Baylor Genetics. Then after that, so we just try to validate it using some different independent data set. One is from the DDD, another one is UDN. And we also use Baylor Genetics data. Actually, this was one of the very challenging cases. We are curious about how we can solve it. So this is some of the updated version of the benchmarking, and actually the previous publications show that our recall rate for the detecting causative gene is better than other tools, and here is a red line is for that our AI-MARRVEL, and there's other tool, and in the middle is from that the data set from the Baylor Genetics. Probably people might argue about, hey, so this is why your method is better because you use the same training and testing data from the same institute. But actually, if we just see that the data, external data, DDD, UDN, you see the same trend can be observed as. So yeah, this is something I want to share before I just start. And so there is a kind of performance-wise, AI-MARRVEL is kind of reliable. And if you're curious about it, you can just use a QR code, try to use AI-MARRVEL. And so actually, we are not only just providing the pipeline, we also provide the web service. And then after we publication in 2024 in New England Journal of Medicine in AI, and it gets a lot of attention. And one of the highlights is going to be that our paper was introduced by the NIH in the NIH director's blog. And then my mentor and our PI is so ambitious about that. We just actually start to provide web services by integrating the pipeline we built, which means we have lots of the data was submitted, and so which means it's a really great chance to test our pipeline. And so after 3 months of the publication, we have received almost 3,000 submissions, which is a lot. And among them, there's about 270 failed submission, which means we just tried to execute it, it just got failed. So, and every time we received, hey, I just learned the AI-MARRVEL, it didn't work, and why, and so we just have some discussion. Everybody say, yeah, but it's kind of really hard to figure out, so I'll tell you why later. And then another, some embarrassing was that we have 50 of incomplete submission, which means we just keep learning a day or long. And we are not sure about whether it's going to generate any result or not. So majority of this was the whole genome sequencing data, and which means it covers a lot of million or 10 millions of the variants. So we are curious why this happens. Still, it was before I joined, and then so I joined last year and as a faculty. And then so first thing was that so I just tried to figure out what's happening. So I found some of the issue. First thing is that people are very flexible for the variant format, and initially we just tried to support that VCF, but some of people has some sequencing data from maybe 23andMe and it has a different format. They tried to convert it. Then VCF was not complete, and we just throw in error. Another thing was that there's no guardrail, and if there's a simple minus silly error, we just throw out the error, which means we really need to build some solid guideline, try to make that to run smoothly. Another thing is that there is some of the error is just a segmented fault and the runtime error, but we are not sure about that or what happened because there's not much logging system was installed. So at the end, so as I mentioned, not many of them, because fortunately majority was from the exome sequencing data. But if we just try to link with the whole genome sequencing data, we are not sure it's going to happen. But so then we are just trying to, after we figure out the problem, we just try to do some post-mortem analysis why this happened. First thing is that we really have the technical depth, because there's the first three of the processor, they are really good at the research, but they just try to only care about publication. So, which means they really don't need to care about, they cared about, so they really, but it's less prioritized care about the allowing all the data. So that's why we have lots of technical depth. Second thing is that, so it's really commonly happens. So nowadays, if we try to perform some multiple processing, it's easy. So the parallel processing, you can just easily use that multiprocessing package in Python or something else. But eventually, we figured out this is not something sufficient. It's more like a premature optimize the code. And then another thing is there's not much to care for, because we are kind of rushed to publication, because otherwise we'll be scooped, we'll not be happy. So that's why we have not much of a careful code optimization. Then I just tried to mention the technical depth because it's really commonly happen. Unfortunately, I just highlight it because I really hate lengthy text. Instead, I just try putting some highlight. But this just say that so the technical depth is really common. Once you have a technical depth, in future, you just have to pay off. So actually, this happened to us and happened in the world, specifically academia. So this is a story how we can just try to, this is something I just mentioned where the technical depth is happened. So this is a very first version how you execute the AI-MARRVEL is with the Docker. Looks great. But so it's simple to use it, just putting some of the parameter, then using just declare what package you are going to use it. Then there's one file called the /run/proc.sh. And if you just open this, it's hard to see. Yeah, there's intention because it's really hard to see that. So you can just try to not sure about that. So which function is where it's implemented. And so basically, this is just purely 283 lines of the bash script without any function, which means there's no expectation of modularization. And then another sad thing was there's not much logging. So there's only one logging, is just measuring the running time, but this is not helpful. And it's, you just see that so there's some the run is keep going, but you are not sure about the way it's going to have when it's finished. So then at the end, there's a lot of the file paths are really hard coded. So if you just change one thing, and you probably change other things. So then after I just see that this, and I just say, oh, we need to change this. So, and then so my go-to solution was Nextflow. Here's why. First thing is before I joined here, I have 1 or 2 years experience using the Nextflow in the industry. Initially, it also has some like some of running code, but after I get familiar with that, I see the some full capability and power of Nextflow, and not only just organizing data, and so also it is really flexible for the any of the like some computing environment. And so my strategy is very intuitive and simple. Start with the shell script. I just try to segment it the bash script into multiple segments. Each segment is going to be the module and the process. After you just try to make it some magic, but but what I can tell you is before I telling the story later, so I really wish to have that the secret AI so that probably I can just try to say, hey, this is my shell script. Then so why don't you just try to convert it? And then, but anyway, so after that, so you are able to see that some really nice diagram is made by the Nextflow function. So I think the conversion was kind of straightforward, but there's kind of cumbersome because if you see that the shell script, the line of shell script, you only have three of the input parameters, mostly file paths and some reference genome directory. But actually, if you see that the actual implementation in the Nextflow as a process, and we see 3 and 6, they are mismatched. Why this happened? It's because there's a script. This script has some hidden file path. It's hard-coded. And which is not explicitly mentioned. So just try to make our life difficult to debug and try to fix. So instead, what I did was our team did try to take out all the file paths into parameters so that we can just try to see that what kind of file is required. If we need try to use it, so for the testing, we can just simply change the parameter without just try to changing the script. That's something we tried it, and it's kind of working. And another thing I want to mention is this was the feature. I can live without this because after sometimes happenings for the debugging optimization, you can just try to go to your work directory and you just try to say the bash.command.run. It just try to automatically reproduce that run or errors, and then after that you can start with the investigation, and by just modifying the bash script inside here, and you probably can just try to change that to see that what's the best way you can figure out fix this. Yeah, this is highly recommended. So I believe there's a more better option, is nicer option, but this is something I just try to emphasize that this really kind of big live for the debugging the code. But this is not the entire story because there's a lot of story, but this is a little bit out of topic. First thing is we really spend a tremendous time for the code optimization. Not only code optimization, we even need to change the algorithm itself. And then this is, I wish try to share that story in future. We also use that Nextflow for the model retraining. This we probably can just, I really wish I have another time to try to share my story. And this is the very first version of the Nextflow. Then the really nice profiling, and you can easily see the bottlenecks there, and we need to change it. After we just do some optimization with the help of the Nextflow, initially it was 7 minutes, but now it's 60 minutes. It's okay, but here's the thing: this input is 10 times bigger than the previous one. So which means that if we just without optimization, you probably can see that probably expected the running this in hour, but this one is more like 6 minutes, even faster. So then another thing is that after that we realized still has some issue for the whole genome sequence data. Majority of there's a Python script that consumes a lot of memory. So then I was thinking that what if we just try to split the VCF file into multiple like chromosome level? Then what will happen? Then I tried it, it really worked greatly. This is an example about how we can optimize by the chromosome level. So at the end, this is something I just tried to share that. So the left one is going to be the first version of that running time. First version is our scale. Unfortunately, this kind of the alignment of the font is off, and this is in our scale. And the blue one is from the Nextflow. So, and you see that there's some the substantial difference. And another thing is the scale is 10 to the x, which means difference is the order of magnitude, which means I should try to thank you the Nextflow and all the community, try to having this really nice tool. Yeah, this is not the end of story, and so we have some upcoming things. First thing is applying the NF core guideline and so automation using the Nextflow. Also, we are kind of actively seeking like some integration of our pipeline with some Secure platform. Yeah, this is my end of story, and thank you so much for try to listen to my talk. And I try to acknowledge the team, especially Jaehyun and Sunyoung and Chao Jong and my mentor, Dr. Jang Dong Liu. Thank you.
Thank you so much. That was a very, very relatable story, I think, for a lot of us. We have a comment. I think it's worth highlighting. Angel saying, loving the real-life view of how to move from an initial implementation to more robust workflow after some initial success. And people are agreeing. I think this is a great example. We don't have any specific questions. Does anybody in the room have a question for Hyun-Hwan? Otherwise, if not, thank you so much for speaking. It was really great.